Algebra, we are wrapping up Unit 1 with CO8, which is writing and interpreting an arithmetic sequence. We started talking about this yesterday. Your job was kind of do this top part, get as far as you could. But I want to go back to what arithmetic sequence means. What does the word arithmetic mean? We defined this yesterday. You didn't have to write it down, but arithmetic. Nolly, no? Josie? The word arithmetic doesn't mean pattern, but sequence does. Okay. One of the meanings of sequence is like a continuous pattern. Arithmetic, adding and subtracting. Okay. So an arithmetic sequence is a pattern involving addition and subtraction. Okay. And so we see an example of this here, right? Because you have this table. It's got the time in seconds 1 through 5. The first time is 16. The second, 48, 3 seconds, 80, 4 seconds, 112. And your job is, what is the distance after 5 seconds? Who's got an answer that they are bold and confident with and want to share? Yeah. 144. And Mia, how did you come up with that?
I added 32.
And why 32?
Because that's like how many you add for each one.
Right. There's a pattern here, right? Going from 16 to 48 is an addition of 32. Going from 48 to 80 is adding 32. From 80 to 112 is adding 32. So it makes sense that from 112 to the fifth number in this sequence is going to be another addition of 32. And 112 plus 32 does give us 144. Okay? So this is an example of an arithmetic sequence because we have a consistent, constant pattern, adding 32, involving addition and subtraction. Okay? So then the next challenge was, what is the distance after 38 seconds? Now you've got two options here, right? You can either continue this table out all the way to 38, which is no fun at all, okay? Or you can come up with some sort of rule for the table, some sort of expression that if you plug the time into the output, the result, the answer is going to be the distance at that particular time. Did anybody come up with something here? For an MCU button. Gabby?
Wait, I just have an idea. So like x times 32 minus 16.
X times, I'm going to replace X with T just for the time here. So 32, sorry, not 3T. 32T minus 16. Now you said that was a guess. How did you come up with that?
Well, it's because like each time is plus 32, but the first time it was 16, so it was minus 16.
Okay, should we test this? Right? If we plug in 3 into this expression here, what should it equal? Based on the table. If we plug in 3 into this expression, what should the result be if it works? Not 112, 80, right? So 32 times 3, that equals 96. 96 minus 16 equals 80. What if we plug 5 in there? 32 times 5 is 160. Minus 16 equals 144. I think you found it. Job well done. Noel, are you going to be okay? Hold on. We're gonna. We're going to. Well, hold on. Where's my? Okay, we're going to go. Well done, Gabby. Well done, Gabby. You did it. That's the rule. Okay? Now, so let's solve this now. Okay? 32 times 38 seconds minus 16. Did you get that value there? Not 1,000, but you're close. What's 32 times 38 minus 16? Someone with quick tell Nolan and come back. Zoe, 1200. Okay, so after 38 seconds, the distance of this object will be 1200 feet. Okay, come back. Well, you were out. You missed the MCU. Should I play it again so you can hear it? Okay. And so here's the thing, right? Only one person in the class was able to come up with this rule from the table because it's difficult, right? It's not an easy thing to do. In fact, I even recognize that. It says, since sometimes writing a rule for a situation can be difficult and making a table all the way out to 38 seconds can be tedious, luckily there is another way. And that's where the arithmetic sequence comes in. Because take a look what we have here, right? We have a sequence, a pattern involving addition and subtraction, or subtraction, in this case adding. We're adding 32 to get from term to term, right? So the way around writing that rule, we can use an arithmetic sequence, which the definition of it is a constant, or I should say common, we'll use that word common, a common pattern with addition or subtraction. A common pattern with addition or subtraction. Okay? And what the arithmetic sequence formula is, and it's a key point, so please put this on a help sheet when you make it for the test. AN equals A1 plus the difference of n minus 1 times D. Yikes, right? Okay, this is a lot. Okay, so first of all, let's kind of work through the different variables here so we can see exactly what this is. Okay, AN represents the nth term of a sequence. It is the answer, right? It's what we're trying to find. The nth term. Maybe it's the 38th term. Maybe it's the 50th term. Maybe it's the distance after 65 seconds, 100 seconds, 1,000 seconds, right? Whatever number that we're plugging in to the formula that Gabby gave us earlier, that's the term we're trying to find. First it was 3, then it was 5, then it was 38, okay? But it's basically what you're trying to find, right? So, skipping down to n here now, the variable n represents the number of the term you want. Okay? The number of the term you want. Which, for our example, Nolan?
What's the first letter?
The nth?
Is it just an N?
NTH. NTH, like fifth or sixth, right? But it's the n. Right? The number of term what? What did we plug in the first one? What we wanted to know the distance after 38 seconds, right? So in our example, we wanted the 38th term of the sequence. We knew that the first term was 16, the second was 48, the third was 80, the fourth was 112. We calculated the fifth to be 144. Ultimately, we wanted to know what the 38th term was. Okay, that was our n here. A1. Now, notice the position of that 1. It's a lowered 1, right? It's not raised. It's not a power. What does it mean when you've got a smaller number that's kind of lowered versus raised? Raised would be a power. What is lowered? You've seen this before. If you recall the formula y2 minus y1 over x2 minus x1, right? Formula for slope. That y2 and y1, those aren't powers. You're not squaring y. What does that mean? In that formula, what do the 2 and the 1 represent? First or second, right? So here it's the same thing. When you have a lowered number, it refers to order. We want the first term. The first term of the sequence. Okay? The first term of the sequence, which in our example of above, that chart, what was the first term? Before we started adding 32 over and over again, what term did we start with? 16. Okay? And then D stands for the common difference. Also, consider it the pattern. Okay? In our example, what was the common difference? What was the pattern? What were we doing to get from term to term?
32.
Adding 32. Right? So these three things right here are what you need in order to get the answer. You need to know the term you're starting with. That's the A1. You need to know the term you want to find. In our case, it was the 38th term because we wanted to know what it was after 38 seconds. And you need to know what the pattern is. And it was adding 32 across the board. Okay? So when we write this out, now it says write the formula and calculate the distance after 38 seconds. We already know what the answer should be. Now we're just proving that the formula works. Okay? So AN equals A1 plus N minus 1 times D. Start with that. Write the whole formula out. It's the same thing that we have up here. Right? AN equals A1 plus N minus 1 times D. And because we want to find the 38th term, this is what tells us that. A38. Remember, that's our answer. This formula will tell us what the 38th term is. Okay? What was our first term? What did we plug in for A1? 16. Right? We have that here, the first term. Plus, in parentheses, there's that N again. And if we replaced N with 38 here, we're going to replace N with 38 here. Why 38? Because that's the number term of the sequence we want to find. We wanted to find it after 38 seconds. So we want the 38th term. The minus 1 is always there, and we'll get to that in just a little bit, why it's in there. And then we're multiplying by that pattern. The pattern was adding 32, so times 32. In your calculators, go ahead and type this exact thing. 16 plus parentheses 38 minus 1 close parentheses times 32. And if you get 1200, you've done it correctly. Did you get it? Anyone not get 1200?
No, I got it.
You got it?
Yeah.
Okay? Because if you can't put this in your calculator correctly, it's going to be very difficult for you to get the correct answers come on the test. Okay? So make sure you have a calculator. I don't have many spares. And make sure you can enter this in correctly. Anyone have any questions? Right? And this equals 1200, right? So our answer, the answer to this expression, the 38th term, is 1200. Much, much simpler to do than try and writing that rule for the table. Okay? All you need to know is the first term, the term you want, and the pattern. Those three things, and you can get it. Okay? So let's kind of start slow here. We're only going to start with the first term and the pattern. But it says write an arithmetic sequence of at least 4 terms using the given first term and the common difference. So I'm giving you that A1, okay, that first term, and I'm giving you the pattern, the D. Right? So with an A1 of 17 and a pattern of 6, we know 17 is where our pattern is going to start, our sequence start. What number will come next? If the common difference is positive 6, remember that's the pattern, we start at 17, what would come next? Don't think too hard about it. Well, that's adding 1. Our pattern is 6.
23.
23, right? Why 23? Because we're adding 6. That's the pattern, plus 6. So, Zoe, what would come next? 29. What would come next? Nolan? 35, right? And there we have the first 4 terms of the sequence with a starting number of 17, that's the A1, and a pattern of 6. Okay? The next one. This time, what number are we starting with? Peyton, what's the first number of the sequence?
-4.
-4. William, what's the pattern?
-3.
-3, which means are we adding 3 or subtracting 3? Subtracting 3. So what number would come next in the sequence? Zoe? -7. Then? -10. Then? -13. Good. Do the last one on your own. Okay? Write the first 4 terms in an arithmetic sequence with the given information. What are we starting with? 5. The pattern is -11, so what number comes next? -6. 5 minus 11, -6. Then? -17, and finally, -28. Okay? Questions so far? Okay. Next page then. We amp it up a little bit. Now we're using all 3 of the information that you need to write an arithmetic sequence. Okay? Says find the nth term of the sequence, put the values in the formula to solve. So we have our first term, right? We have the pattern, and now I tell you what number of the sequence we want to find. We want to find the 12th term. If we start at 6 and add 4 for the pattern, what is the 12th term in the sequence? You could, if you wanted to, start at 6 and add 4 over and over and over and over and over and over again until you get to 12, right? Or you could use the arithmetic sequence. AN equals A1 plus N minus 1 times D. We're going to use the sequence because later on down the row, I don't want to be adding 71 101 times. Okay? This is much more efficient. AN is A12. Remember, that's our answer. That's what we want to find. What's our first term? 6. What goes in for N? What term do we want to find? 12. Minus 1. Why? We'll talk about that shortly. Times D. D, the pattern, we're adding 4. So times 4. Go ahead and calculate this. What is 6 plus 12 minus 1 times 4? What is the 12th number in this sequence? Landon. 50. Do I have a second?
Yep.
That is correct. If you didn't get 50, let's talk about it. Anybody? Not get 50? All right. For another MCU, it's never been done, a second MCU in the same period. Why the minus 1? Why is that part of the formula? We do it every single time. Why the minus 1? Any thoughts? Any ideas? let's do a couple more. See if you can come up with it. Okay, the MCU offer's still out there. Yeah.
It's because if you did everything else without the -1, you would get one number over the answer.
And why would that be, Landon?
I didn't think I was gonna get it right. Because if you just put, because then wouldn't it just be like 6? It'd be like 6n or something.
Okay. If you didn't subtract 1 from n, your final answer would be one number beyond what you want. Why? Because you're already given the first term. Okay? You want to know, after adding 4 to get to the 12th term, if you know what the first term is, how many times do you actually add 4 to get to term number 12? If you know what the first term is, 6, how many times do we actually add 4 to get to the 12th term of 50? This is term number 1. This is term number 12. That's what we wanted. We knew the first term. How many times did we actually add 4 to get there?
11.
Only 11 times, because we knew what the first term was. So the -1 is there because this really describes how many times the pattern is applied. Good job, Landon. Perfect. Okay. Oh yeah, go get no. That's why we have the -1. Okay, next one. The first term is 4. The pattern is -3, which means we're subtracting here. Our pattern will be decreasing. Okay, and we want the 80th term. So an equals a1 plus, in parentheses, n minus 1 times d, which I'm not going to put the, okay? n is 80. This tells us we're looking for the 80th term. What's our first term? Where do we start? 4. We already know n is 80 because that's what we're trying to find, the 80th term, which means we're actually going to be subtracting 3 79 times. Because to get from the first term to the 80th is 79 movements. That's why the -1 is in there. And we're multiplying by -3. Make sure you put the multiplication symbol in there. And don't just put -3, because that's going to greatly affect what the final answer is. All right, 4 plus, in parentheses, 80 minus 1 times -3. What is the 80th term of the sequence? Two people have it? Any more?
But I almost got it.
Okay. 3, 4. Make sure you can do this, right? Calculator is a wonderful tool, but we got to make sure you know how to use it. What did you come up with? -233. Do we have a second on that?
Yeah.
That is the correct answer. Okay. Now, if you started with 4 and subtracted 3 79 times, you'd get -233. But ain't nobody got time for that. Okay. That's why we have the formula. Try the last one on your own. A1 of -50, D of 71, and N of 101. There's the formula. Plug in the values. Solve it. So, A101, we're looking for the 101st term, equals the first term of -50 plus 101 minus 1 times 71. And that's what you put in your calculator right here. Negative 50 plus parentheses 101 minus 1 times 71. Huh? Well, kind of. It's just more variation with this. But yeah, this is it. You folks are really quiet today. Was the science test that hard?
Yeah.
Are your brains just like...
He scored it out of like, what was it? 110 points.
Like one question wrong.
It walked back to one.
Well, it's the same thing as each question being worth 1 point and having 11.
No,
it's not.
After that,
Yes,
it's
No, it's the same percentage. Like if you get one wrong and on an 11-point test, you get 10 out of 11. 100 out of 110 is the same percentage. It affects your grade a lot more, being 110 points versus just 11, but it's the same percentage. Either one. Anyway, what did you come up with here?
Still.
Yeah, it's a lot.
100.
Well, I'm gonna make the math test out of 200 points.
I'm not gonna do it.
Just yeah. What'd you get? What is the 101st term? Yeah. 7,050. Do I have a second on that? If you didn't get 7,050, let's discuss. Did you get 7,050?
Yeah, that's
Yeah. The rest of the page. Penelope, do you have a question?
No, I just got the answer.
What did you get?
Doesn't matter.
Well, it does because if we got to figure out.
7,150.
Okay, so I think you forgot to subtract 1.
I probably did.
Yeah, make sure you subtract 1 in the formula. That's what catches a lot of kids. Okay. So down below it says determine if each sequence is arithmetic. If it is, identify the values of A1, N, and D. Then find the nth term. So first of all, you've got to decide: is this sequence arithmetic? Is there a common pattern with addition or subtraction? The first one: 15, 22, 29, 36. Is there a common pattern there with addition or subtraction? Adding 7. So is it arithmetic? Yes. So we can start to kind of piece this together here. Okay. What's our first term? Where does the sequence start with? 15, right? What's our end? What number of the sequence? What number of the sequence do we want to find? The 12th, right? Find A12. That means the 12th. And the pattern, as Dominic said, we're adding 7. Now that you've got those 3 values, it's exactly the same as what we just did up top. You have the first term, you have the N, you have the D, plug it in. Okay, it's the exact same thing, right? But first you've got to determine, is it arithmetic? Not all 4 of them are. There's one that is not. There's your hint. And if it's not arithmetic, you can't use this formula. There's nothing you can do. Say, I'm done. Okay? But only one of them is not an arithmetic sequence. Then down at the bottom, when will you ever use something like this? It says your bank account currently has $160 in it, and consider today day 1. This is where you're starting with. $160 today. You begin adding $8 each day. How much money will be in the account on day 50? Okay? So if you have $160 today, and today is day 1, what variable does 160 represent? A1, N, or D? A1, right? This is where you're starting. The first term of the sequence. You add $8 every day. So every day your account is going up by 8. Is that N or D? D. That's the pattern. How much money will be in the account on day 50? You want to find out a future result. Well, the only variable left is N, and it makes sense, right? This is what we want to find. So once you have these 3 variables, plug it into the formula. Okay? Word problems are just harder because you got to pull out the information and decide what is this, what is that, right? And you have 2 more word problems after that. Okay? Questions, comments, concerns, complaints, comments, congratulations, or criticisms on this? Nolan.
I get your.
Thanks, Nolan. Appreciate that.
It's actually
That's what I'm ready.
That is true. Anybody else? Okay. Your 200-point test will be on Thursday and Friday. This is 200 points. Each test or each question is worth 31 points. The math doesn't math, but there we go. This is due tomorrow. You will have a practice test tomorrow. That'll be due on Thursday. You'll hand it in before you take the test. Remember, half the test is without calculator, half the test is with calculator. Bring your own calculator. I only have enough to go around, and I don't like people sharing because if you bring your own tools, you should be able to use them. Okay? All right. That's how that.